Given the amount of reactants used, I can calculate the maximum amount of products that will be produced along with which reactant is the limiting reactant. In other words, for you right now, right? I mean, I might as well just have done that. Good. All right, so we make a pot of chili. And what side dish is just perfect for chili? Okay, okay, Fritos, yes. What sandwich is perfect?
Just give us the answer.
Yeah, I'm just going to give you the answer. I don't care what opinion you have. Let me tell you the truth. The optimal sandwich is a grilled cheese sandwich. A grilled cheese sandwich. Okay, so let's say that our family I made some chili for you guys, and I come in with 2 bags of bread that have 10 slices each. So there are 20 slices of bread, right? And I give you 20 slices of cheese. Now, everyone knows that in order to make a decent grilled cheese sandwich, you need a ton of butter and 2 slices of cheese, right? We can't have 1 slice of cheese. That's too much. So, we have enough. I'm sorry. We have enough bread to make how many grilled cheese sandwiches? 10. Okay, we have enough cheese to make how many grilled cheese sandwiches? 5. Because it takes 2 slices of bread plus 2 slices of cheese to make 1 grilled cheese sandwich, right? But wait a second, I thought we had enough to make 10 sandwiches. Why can't we make 10 sandwiches? The cheese, Alec, you're brilliant. The cheese is limiting you to 5 slices. To 5 sandwiches. So in chemistry, we would call the cheese the limiting reactant. What about the bread? Do we not have enough bread to make 10 sandwiches?
Yes.
Will we make 10 sandwiches?
No.
So we're basically going to make how many sandwiches?
5.
5, and what else will be left over?
Bread.
Okay? In chemistry, we will call the bread in excess because there was too much of it. This is what happens in the real world. In the real world, a chemical engineer may need to make a certain amount of stuff. He will have 2 ingredients, one that's expensive and one that is cheaper. He uses the expensive one to limit the reaction, and he uses the cheaper one to just make sure that the reaction goes all the way. Okay? So, the cheaper one becomes the in excess. It'll always be left over. Is that bad? Yes, it's bad because you lose a little bit of money. Would it be better if we use the expensive one in excess? No, because do you really want your leftover to be the more expensive one? If you're in McDonald's and you have to make, you know that you're going to need to make 500 burgers. Do you want to have too much bread at the end of the day or too much meat at the end of the day? You want to have too much bread. Why?
Because that's less expensive.
Probably a bun in McDonald's probably costs 4 or 5 cents. The meat may cost 50 or 60 cents. Okay, so you definitely, if you're going to waste something, you definitely want to waste the more expensive one. Okay, these questions are not going to be very different
From what?
from what we did on Friday.
Okay.
Here we go. Suppose 25 grams of nitrogen gas. Calculate the mass of ammonia. That's what we did on Friday. What makes this one different?
We only had 25 grams of
There's two things.
There's two things. On Friday, I said, hey, you've got 25.0 grams of nitrogen. Tell me how many grams of ammonia. That's what you did on Friday, multiple times. But today, I'm going to say, hey, you have 5 grams of hydrogen and 25 grams of nitrogen. Okay, here's your situation. One of these, if you work it out, will give you the wrong answer. The other one, if you work it out, will give you the right answer.
Which one though?
No, you get to choose. You got a 50-50 shot. You either get the right answer or the wrong
How
answer.
do you know if you get the wrong answer?
You just it's just random.
So then we'll get half of our homework.
Yes. No, of course not. Okay, here's the situation. One of these will give you the right answer. One will give you the smaller answer. That's your limiting reactant. That's the one that ran out first.
So you have to calculate.
The other one will give you 10 sandwiches. One will give you 5 sandwiches, and that's the right answer. The other one will give you 10
The
sandwiches.
smaller
So
figure.
the answer is always the smaller one.
So we have
Okay,
to calculate
so
those out.
which one is going to give you the smaller one? Esther? Which one? Okay, if even Esther can't figure this out, guess what? None of you can figure it out. So, Allison, what are you going to have to do? You said it a few minutes ago.
Turn back.
Okay, which one of these you're going to have to do?
Both of them.
Both of them. We're going to have to work them both out. One will be too much, and the other one
It
is
will
the
be
right
the
amount.
same.
Okay, so Noah, you weren't here. Maybe you can pick this up because we do it. It's a pattern, and we do it always the same way. Okay, so we pretend that we live in nitrogen land, and that we've been told that we need to move to ammonia land because that's what they ask. Calculate the mass of ammonia. Okay, so the first thing you do, you go to the bank because you want to exchange all your grams of nitrogen currency for a currency that you can use in nitrogen land and in ammonia land. Kind of like the euro, right? Whenever you go to any bank, they will say the same thing to you. We will give you 1 mole for the formula mass of that country. So the formula mass of 2 nitrogens is 2 times 14, 28.0 grams. So notice that now we have gotten rid of our old currency. Now we need to move to ammonia land. So we need to go from nitrogen land and move to ammonia land. Noah, before we move, it might be a good idea to see what the cost of living difference is. And that's why you look at the Chamber of Commerce information, which is your balanced equation. And what they tell you is if you spend 2 moles in nitrogen land, you will have to spend 2 moles in ammonia land. Okay, so it's 2 moles to 2 moles. Yes, Simon.
I'm kind of confused. You have 2 nitrogen tubes, but I notice that you have 2 ammonias, and there's only 1 nitrogen in each ammonia. It's not a balanced equation.
You're right.
Shouldn't it be 1 mole of nitrogen to 2 moles?
Yeah, you're right. You're right. You're right. Man, you're the first one all day that has noticed that. Good job. Good job. Okay, so how does that change then? What that changes is that you have 1 mole of nitrogen. You will have to spend 2 moles of ammonia. So, Noah, you've now moved to ammonia. But the currency you use is moles. Everyone makes fun of you because no one uses moles in ammonia land. They always use grams. So you go to the bank because you're afraid of looking bad in front of people. So you go to the bank and you say, I would like to exchange my moles for grams. And it doesn't matter what bank you're in. They'll always tell you the same thing. For every 1 mole, we will give you the of this country, which in our case, it's 14 plus 3 times 1 is 17. All right? Noah, they can calculate for us. You go through this with me again. Now let's do it for hydrogen. Okay, first place you go to, Noah, is what? You go to the bank to convert from grams to, which is the unit that you can travel with. Okay? Then you're going to travel from hydrogen land to which land? To ammonia land. And they make fun of you in ammonia land because you use the mole. So you want to convert it back to? Okay. So when you convert money from one type to another, you have to go to the bank. And the bank will tell you, we will give you 1 mole for the, which is 2.0 for hydrogen. We will give you 1 mole for the, which is 17.0. Now, in order to figure out what the cost of living difference is between hydrogen land and ammonia land, where do you go? The what? The equation. And what is that ratio? If it costs you 3 moles in hydrogen land, it will cost you only okay. Here we go. Who's got the top? What? Can we get a confirmation on that? Yes? Yes? Close enough. For Lenoir. 30.4. What about the bottom number? What about the bottom number? 5 divided by 2, enter, times 2, enter, divide by 3, enter, times 17.0. What? Are we sure? Yes? Okay. Now, listen very carefully. Here comes the important part. Listen. So what does this mean? This means we have enough hydrogen to make 28.3 grams if it is reacting with nitrogen. And if nitrogen reacts with hydrogen, you have enough to make 30.4 grams. How many grams will you really make? The smaller number. Why? Because when does hydrogen run out? At what point does hydrogen run out? At 28.3. Do you need hydrogen in order to make ammonia? So does it really matter that you still have nitrogen going? I can make more. I can make more. There's more of us. I can make more. Does it matter? No. Nitrogen is like the bread in our example. You had enough bread to make 5 more sandwiches. Did you make the sandwich? No, because you ran out of cheese. So at this point, you run out of cheese. This is called your theoretical yield. What that means is, in theory, that's how much you should make. This guy is going to be called the limiting reactant, the LR. Because once that reactant is gone, what happens to the reaction? It stops. This one is called in excess. INXS. In excess. Because you have a lot of it. You have a lot of it. You have a lot of it. That's it. That's the wrinkle. Let's do another one. That's it. That's all you have to do. I mean, all you basically have to do is one more than you did on Friday. And figure out which one is the lower one, the smaller number. If you get trouble with that, ask your little brother and sister. They could probably tell you which number is the smaller one. All right. Hopefully this one is balanced correctly. What do we know? We know we have 18.1 grams of that and 90.4 grams of this. And they want to know how much nitrogen is going to be made. So which one should we use? Which one will give us the right answer? We don't know. Here we go. Noah, you think you can do this one all by yourself? Let's see, because if you can, then you are good to go to do Friday's homework as well. All right, so grams needs to go down here. What's the first unit we convert to? How many moles will the bank give you? For every? Very good so far. Okay, so now you are in the international unit of mole. How do you get rid of moles of ammonia? Negatory. Why would you want to convert you want to now travel to your new country. What is your new country? Is your goal. Okay? In order to travel there, what unit must you use? What unit is internationally accepted? Because a gram of ammonia is different than a gram of nitrogen. They're not the same thing. But a mole of ammonia is the same thing as a mole. Okay. Now, where do you find out how much, relatively speaking, how the cost of living difference is? Okay, so what is that ratio? Who gets the 2 and who gets the 1? I agree with you. Okay. Now we need to get rid of moles of nitrogen. They'll make fun of you if you don't use moles, grams. All right. Go on, Noah, see if you can do it on your own piece of paper. I'll do it quietly up here. You guys beginning to see why I kept telling you, use train tracks, use train tracks, use train tracks. Stuff is coming down the pike that will require you to use train tracks. And you guys, no, I can use ratio. And I can, no, use train tracks. Yes, sir.
Will this be posted on YouTube?
Yes, sir. Have you guys noticed that the last 3 blocks are exactly the same? If they're not, You're doing something wrong because you're always converting to the same thing. You have to convert to the same thing, or else you won't be able to figure out who the limiting reactant is. You have to compare apples to apples. Can't compare apples to oranges. All right, do we have an answer for the top number? 14.9, she asks with a question. That's what, okay, good. That looks good. And the bottom number?
10.6 grams.
Okay, so we have two answers. Which one is the right? So we call this the, who's our limiting reactant, therefore?
Not zero, so
And who's in excess?
that one.
We have to say what's like the elimination.
Yeah, because there's going to be some multiple choice questions that are going to be as easy as, which one's the limiting reactant?